So we're just going to do some sample problems involving derivatives and limits and velocity. So here's our first problem. I'll give you a minute to read it. It's a problem about average velocity. Okay, so hopefully that was enough time for you to read it. What is average velocity? That's rise over run. And the easy thing is the run, which is just 7. That's 7 seconds that is passed by. Now what's the rise? Well, that's 9 squared plus 9 minus 2 squared plus 2. That's a change in the function over those 7 seconds. So then we have 90 minus 6 over 7 equals 12. All right, let's do another problem. Let's find the value of x where the tangent line is horizontal. For f of x equals 4x squared over x plus 2. So first we take the derivative. F prime x equals the derivative of 4x squared, that's 8x, times x plus 2 minus 4x squared times the derivative of the denominator, which is just 1, so you have 4x squared over the denominator squared. That'll give us 4x squared plus 16x over x plus 2 squared, once you simplify that algebraically. So this quantity in the denominator is always a non-negative value. Okay, so this function is defined for x not equal to -2, because when x equals -2, the denominator is 0. But assuming x does not equal -2, this function equals 0, f prime of x equals 0, when the numerator equals 0. So 4x squared plus 16x equals 0. And so I'm going to factor that into 4x times x plus 4. And so therefore the derivative equals 0 when x is equal to 0 or -4. And since that doesn't coincide with -2, we're fine. So the tangent line is horizontal at x equals 0 or -4. Okay, now we're just going to do a few very straightforward differentiation problems. Let's differentiate the function natural log to the 5th. So we differentiate the outside function times the derivative of the inside function, which is 1 over x. Now suppose we had that same problem, but we were differentiating log base, say 2. Okay, so how do you differentiate log base 2? Well, remember that what does it mean to be log base 2? It means that 2 to the log base 2 of x just equals x. It's the inverse of exponentiation of 2. So that means that if I take natural log of both sides, I can get the derivative of log base 2 as in terms of natural log of x. So when I do that, I get log base 2 of x natural log of 2 equals ln x. So log base 2 of x equals ln x over ln of 2. Okay. Therefore, if I differentiate this, I'm just differentiating this. Where ln of 2 is just a constant, so I pull it out. And the derivative of ln of x is just 1 over x. So that's the derivative of log base 2. And of course, you can substitute any number you want here for 2.